Good afternoon. So today I'm going to demonstrate how we can explain the movement of a yo-yo using work energy principle. So I have a yo-yo in my hand, and honestly I've been trying for the last half hour to play with it, and I'm horrible at it, but I'm going to try it again. So here's my hand, and I let the yo-yo go down from my hand. Then as soon as it reaches almost the bottom of it, I pull it up with the force F, and when I'm pulling up, my hand moves with the distance of S, and let's say it goes down distance of H. So let's try. Nope, didn't work. Let it go. Whoop, 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 whoop. I was trying to look at the camera and I messed it up. Anyway, so the point is not me trying to play yo-yo. The point here is to explain how we can use working as a principle for a yo-yo. So as I said earlier, let's say we have a yo-yo and of a very small mass of a string attached with it, and I have a hand here. So I let the yo-yo go down, and when I let the yo-yo go down, suppose initially it was at height, this height, and it got displaced by a height h, right? And as soon as it goes down, for a yo-yo to come back up, I have to lift my hand up. I move my hand up a little bit so that it can come back up. Even though I'm terrible at it, I still try it. Anyway, so how can we use working energy principle in that? Okay, there are two systems that we can consider in this aspect. The first one is a point particle system, and the second one is a real system. Now, the difference between the point particle system and the real system is, if we use a point particle system, we can calculate the change in the translational kinetic energy of yo-yo. Because the point particle system only deals with the change in the translational kinetic energy. Now let me introduce what the point particle system is. The point particle system takes in consideration the center of mass of the whole system. So if my system is a string and yo-yo, the point particle system only cares about the center of mass of yo-yo. So, and also when we calculate the work done in the point particle system, the work done will be the net force on the center of mass dot the displacement of the center of mass. In this case, the displacement of the center of mass was h. Now, so if we want to use working as a principle, so what are the forces acting on it? We know that work equals change in energy, right? So the forces acting on it there are two forces. One, the force by my hand, which is upwards. Next, there is a force due to gravity, because yo-yo has certain mass, so there will be force due to gravity mg downwards. The net force is, since the yo-yo is going downwards, it will be mg minus f, and the net distance, the displacement of the center of mass is dot h. So using that, we can find the translational kinetic energy using the point particle system. Now, if we were to use a real system, the real system doesn't take in consideration only the point. It takes in consideration the whole system. In this case, yo-yo and the string, right? So what are the different forces acting on the real system? The force by my hand and the force due to gravity. Now, we have to be careful here. Why? Because in the point particle system, we only care about the displacement of the point particle to find the work done. But in the real system, the displacements are different. For my hand, the force due to my hand, the displacement is no longer dot h. The displacement is actually the s, or d, we can say d or s, by which my hand got displaced. So in real system, the work done is calculated by force dot the displacement of the point of application force. In this case, the point of application there, so it went up like that, so displacement is d for that f. For mz, now displacement is same as before, which is h, as the yo-yo went down, because the point of application of the force of gravity in the real system is center of mass this yo-yo, and the yo-yo got displaced, the point of application force got displaced by h, so force work done will be md dot h. Now, after explanation of that, I would like to point out one more thing. The difference between the real system and the point particle system, the main difference is that the point particle system only deals with the point center of mass. The real system deals with the whole real system. The point particle system only has translational kinetic energy. The real system can have translation kinetic energy, rotational kinetic energy, internal energy, and even potential energy. And we have to be very careful while calculating the work done in point particle system and the real system. In the point particle system, the work done, we calculate by the net force. We calculate net force, and we get the dot product of net force and the displacement of the center of mass. But in a real system, there are different forces acting on different part, so we calculate the work done by adding the work done of each forces and the work done of individual force will be that force dot the displacement of the point of application of that force, not the center of mass. Like for example, in my hand, with the work done by my hand was the force F and the displacement S or D. And the work done by gravity was mg dot h, the height of the yo-yo. Now, after explaining the concept difference between real system and the point particle system, let's solve this problem to get the mathematical equation of what the mathematical equation would look like. So let me try to find a problem. Let's see. All right. So here's the. I don't know if it will let me turn again. So I will explain that in the following video, in a very short video. Thank you.